In this video, I'm going to do two composition stoichiometry problems. So I'll be doing problems that just have one substance. So we're going to start by underlining our given and circle what we're looking for. You then put your given over 1. Please make sure you write both parts of your given. It doesn't matter that much for this version of stoichiometry, but when we get to reaction stoich, you're going to want to have both your compound and your measurement. Next thing we do is figure out how many steps we need. So to do that, we're going to go to our unicorn diagram. Now, because we only have one substance, we only need one side. So we're going from grams to particles. Molecules is a particle. We start at grams, but we can't go directly to particles because they're not connected. So we have to go from grams and then follow this line to go to moles, and then we can go to particles. So that means we have 1, 2, 3 factors. Next thing we do is drop down both parts of our units. So grams of SiO2 goes on the bottom. You don't take the number with it, just the grams. So then we find what goes on top on our unicorn diagram. So if we have this tells you what goes on top as well as how many factors you need. So we have grams already. The next one we go to is moles. So we're going to put moles of SiO2 on the top. Then we drop down the moles of SiO2 and we figure out what unit goes on the top here. You can look at the question because whatever you're looking for goes on the top, or you can use the unicorn diagram because it always tells you the units on the top. So if we're at moles, we then go to particles. So you can write particles or molecules here because for this case, the particle is molecules. And that's the units. So now you need to match up your units with a conversion factor to find out the numbers. So for the first one, we have moles on top, grams on the bottom. So if we go to our conversion factors, we find the one that has moles on top and grams on the bottom, which is right here. We have moles on top, grams on bottom. So we already know that 1 will go with moles, and then X goes with grams. Now X, remember, for our conversion factors is molar mass. So we can put a 1 right here, and then we find the molar mass of SiO2. So we go to our periodic table. Si is 28, oxygen is 16. So we have 28 times 1 plus 16 times 2. And that comes out to 60. So that 60 is our X for molar mass. For the next factor, we find the conversion factor that matches up with these units. So molecules on top, moles on the bottom. Molecules on top, moles on the bottom is right here. Remember that a particle can be an atom, a molecule, or a formula unit. So we're going to put in 6.02 times 10 to the 23rd with molecules and 1 with moles. Then to solve this, you're going to multiply across the top. So 15.6 times 1 times 6.02 times 10 to the 23rd. That comes out to 9.39 times 10 to the 24th. And then you divide by everything multiplied on the bottom. So 1 times 60 times 1. Then you divide those, and we end up with 1.57 times 10 to the 23rd. And then we just need our units. So just like with dimensional analysis, your units will cancel. So grams of SiO2, since it's in 2 places, it cancels out. Moles of SiO2 does the same thing. And so you're left with just molecules of SiO2, which is what you wanted. Now I'm going to do one more. So we start and we follow the same process. 175 grams of FeCl2 is our given. We're looking for moles of FeCl2. So we start with our given. Over 1. Now we need to know how many factors it is. So we go to our unicorn chart. We still only need one side because it's one compound. We are at grams, that's our given, and we're looking for moles. So for this one, we only need 2 factors because grams and moles are connected. So we could just go right from grams to moles. The last one, we needed 3 because grams and particles were not connected. There's no line here. So because grams and moles are connected, we can do it in 2 factors. So you're going to drop down both parts of your units. And then the unit that goes on top, you can either get from what the given is or from the unicorn diagram. Either way, it comes out to moles of FeCl2. Now we match up those units with one of our conversion factors. We have moles on top and grams on the bottom. So that gives us this one right here. We put 1 with moles. And then we find the molar mass of FeCl2. So the decimal number on our periodic table of Fe is 56. Cl is 35. So we have 56 times 1 plus 35 times 2. And that comes out to 126. So we put that here. And then we solve. We multiply everything across the top, everything across the bottom, and then we divide. That gives us 1.39. Our grams of FeCl2 will cancel, and so our units will be moles of FeCl2.